We are still in the topic of hyperbola, and in this lesson, we will sketch some graphs, okay? Or we will visualize some graphs. Our goal is really not to produce a near perfect graph. We have softwares that can do that. So our goal here is to visualize the graph of a hyperbola based on the equation, okay? And then we will also do another exercise that is on the equation of hyperbola. Let's say, for example, we are given some conditions about the hyperbola. What is the equation of that hyperbola? So again, we have two sets of equations for a hyperbola. But of course, we are limiting our discussions on hyperbolas whose principal axis is either horizontal or vertical. But of course, there are hyperbolas where the principal axis is oblique. But we will not go there, okay? So these are our two sets of equations for a hyperbola in standard form. First, we must pay attention to the center, of course, which is HK. And then we must pay attention to your principal axis. Is it vertical or is it horizontal? Well, it is horizontal when what appears after subtraction is y, then your principal axis is horizontal, and this is how your graph is going to look like. When the term that appears after subtraction is x, your principal axis is vertical, and so this is how your hyperbola might look like. And this is the relationship between C, A, and B. C squared is equal to A squared plus B squared. Now again, let us pay attention to the patterns here. Okay, so A squared, the denominator A squared, that's the denominator that appears before subtraction. And the denominator after subtraction is always your B squared. We need A to locate the vertices, okay? B is for the endpoints of your conjugate axis. And then we need C to locate the coordinates of your foci. So last time, I also spoke about the general equation of a hyperbola. This is your general equation where A times C is negative. Sketch the graph of the following equations. Y squared over 36 minus x squared over 25 is equal to 1. So our goal here really is not to produce a near perfect graph for a hyperbola. Okay, our goal here is to visualize how might the hyperbola look based on this equation. Well, first we must find the center. And then after finding the center, we must establish the principal axis. Is it vertical or is it horizontal? And knowing the principal axis, okay, it can be either horizontal or vertical, that will suggest to us the orientation of your parabola, of your hyperbola, I mean. Find the vertices. So again, our goal here is not to produce a near perfect sketch of the graph. We just want to visualize the hyperbola that is defined by this equation. So the center here is 0, 0. It's the origin. And let us pay attention to the terms that appear after subtraction. Okay, it's x squared. So this is telling us that the principal axis is vertical. It's vertical. So our hyperbola is standing up. Okay, one branch opens up, one branch opens down. And so our principal axis is this, x is equal to 0. Okay, next, let us look for the vertices. Now A will help us locate the vertices, okay, because A is the distance of your vertex from the center. So A squared is equal to 36. A is equal to plus or minus 6. Again, I spoke about this last time. In the earlier videos, I'm not paying attention to plus or minus the square root of a squared. I always took the positive square root. But I think it's more appropriate to take the positive and negative square roots because that is telling you something. A now is the directed distance of your vertex from the center. So when it's positive 6, that is a vertex that is above the center. When A is negative 6, that will point you to a vertex that is below the center. So these are the vertices, okay? Okay, so let's say, for example, this is the center. Okay, our principal axis is vertical. So that is one vertex. This is the other vertex. So this one is V1. Okay, that is V1. And this one is V2. And this is our center. And with that, we know now that more or less this is how your hyperbola will appear. Sketch the graph of the following equations. Okay. Again, find the center, find the principal axis, find the vertices. The center is 1, negative 5. Now, y, it's y that appears after subtraction. So, our principal axis is horizontal and it's going to be equal to y is equal to negative 5. So this is our principal axis. Y is equal to negative 5. Or one branch of our hyperbola faces to the left, one faces to the right. A squared is equal to 25, which means that A is equal to plus or minus 5. So one vertex is 5 units to the left of your center, and the other vertex is 5 units to the right of your center. Okay? And so these are the vertices. And this is the graph, okay? So C is your center with coordinates 1, negative 5. V1 has coordinates 6 and negative 5. And V2 has coordinates negative 4, negative 5. Write the equation of the hyperbola that meets the following conditions. So we are given these conditions. These are the coordinates of the foci and the vertices. What is the equation? Well, first, we must find the center and the principal axis. And, of course, we must find A and B. A squared and B squared are the denominators of this equation. Okay, so what we do first is we plot these points, okay? So this is one focus. This is the other focus, and that is one vertex, that is the other vertex. So the center is just the midpoint, okay? It's the midpoint of the two foci or the midpoint of the two vertices. And it is equal to 0, 0. So right away, looking at the alignment of your focus and vertex, you know that the principal axis is vertical. That means the principal axis is the line x is equal to 0. So since our principal axis is vertical, right away, okay, so we can now focus our attention to this equation. It's the x that must appear after subtraction. So we already know the center. Okay, the center is 0, 0. Next, we look for a squared and b squared. What is a squared? So a squared here, we just look at the distance of your vertex from the center. 1 is the distance. So a squared is equal to 1. How far are your foci from the center? The foci, one foci is 3 units above the center, and one foci is also 3 units below the center. So C is equal to 3, which means that C squared is equal to 9. We already have A squared. A squared is equal to 1. What about B squared? So we will solve for B squared here. Since C squared is equal to A squared plus B squared is equal to C squared minus A squared, and that is equal to 9 minus 1, and that is equal to 8. We already have the inputs for our equation. We have the center, okay? we have a squared and b squared, and so this is the equation of this hyperbola.